we are taking measurements, when we are taking measurements, what are we actually doing? I want you to share something with me. Measurement, what is it about? What is measurement? Any one of you to share his or her view with us. What is measurement?
Sir, please. Measurement is comparing an unknown quantity to a known unit.
Okay, that's awesome. That's awesome. More views. If you have any different idea as to what measurement is. Yes, please. I'll post the video, so you don't worry. I'll post the video on the platform. Any different opinion of what measurement? Okay. Yeah, go ahead.
Measurement is the process of obtaining the quantity of a substance by using a correct instrument or a given mathematical expression.
All right, that's also fine. So when we talk about measurement, we are looking at determining, just as the two contributions that have come, determining an unknown quantity by comparing it with a standard quantity. Okay, so determining an unknown quantity by comparing it with a standard quantity or value. So whenever we measure, all that we are doing is that we want to compare whatever we don't know to a known one to see how much of it, okay, of the unknown will be for the known. Okay, so how much of it do we have? How much of the unknown do we have in the known? As to whether that will be more or less of the standard or of the known one. That is generally what measurement is about. Okay, now, so what it means is that whenever we measure, there should be a known thing, what we call as the standard. Then we compare the unknown, okay, thing we are measuring to the known one or to the standard to ascertain whether what we have will be more or less or will be equal to the known quantity. Please, are we okay?
Yes.
Okay, and so that is the whole idea of what measurement is. I'll write the definition on the board so you don't worry. Or I'll dictate it so that each one of you can get it. Now the standard, okay, on which the unknown is compared with is what we call as the unit. So unit is the standard or the known quantity, okay, we compare on unknown quantity with. The standard of measurement is what we call as a unit. So quickly, let's put the information on measurement down. Are you ready? I'm dictating.
Yes, please. Yes, please.
So in physical sciences, we deal with a large number of quantities. In physical sciences, we deal with a large number of quantities which we have to measure. Can I continue?
Please, no.
In physical
Please, can you go over it again?
In physical sciences, we deal with large number of quantities which we have to measure. Now, measurement involves comparison with a reference standard. Measurement involves comparison with a reference standard. Measurement involves comparison comparison with a reference standard. Measurement means to compare. Measurement means, can I continue?
No, please.
All right. So measurement means to compare. Okay, measurement involves comparison with a reference standard. Jessica,
Please, I would like to know the definition of a unit again.
I'll give it to you. So
Thank
let's
you.
write on measurement. So measurement involves comparison with a reference standard. And a detailed explanation that measurement means to compare any physical quantity with some standard. Compare any physical quantity to some standard. And to find out how many times the unknown is bigger. Find out how many times the unknown is bigger. The unknown is bigger or smaller than the standard. Is bigger or smaller than the standard. So that is what measurement is actually about. Okay. So sometimes in measurement, let's assume measurement of length. You can take measurement of a physical quantity such as length, and then what you have may be 100 centimeter. If you have 100 centimeter, what it basically means is that, you see, the standard of measurement of length, okay, is the meter. Okay, the unit of length is the meter. And 1 meter is exactly equal to 100 centimeter. So if you take measurement and you get 100 centimeter, then what it simply means is that when we compare this unknown to the standard, we have exactly 1 of the standard. Are we okay?
No,
Yes,
please.
With measurement, we are comparing an unknown quantity
yes, please.
to a known quantity. And the known quantity is the unit. Okay. The known quantity is the unit. So we say the SI unit of measuring length is the meter. 1 meter is equal to 100 centimeter. So when you measure an unknown length and you get 100 centimeter, all that is saying is that when we compare the unknown to the known, it is exactly 1. The ratio is 1:1, or they are equal. That's what I'm saying. If you measure an unknown quantity and you get 50 centimeter, what it also means is that when we compare the unknown to the known, you have half of the known. I hope you all stay here.
Yes, please.
So that is exactly what it means. However, if you also take measurement, an unknown quantity, and you get, let's say, 500 centimeter, what it simply tells you is that you have the unknown quantity being 5 times the known quantity, because the known, which is the standard, is exactly 1 meter or 100 centimeter. That is what it means. Okay, let's continue our note on unit. What we mean by unit. Unit. All right. So the standard with which a physical quantity, the standard with which a physical quantity, okay, is compared with, or is compared. The standard, the unit is the standard, okay, with which a physical quantity is compared. So we are comparing an unknown to a known. The known is what is the standard, and the standard upon which we make our comparison of the unknown is what we call as a unit. Okay. So unit is the standard with which a physical quantity is compared with. Example, we have kilogram. Example of unit, we have kilogram. Justin, your hand is up.
Mr. Dweb, kindly come again.
All right. I'm sure you are done writing what is here. Can I clean it?
Yes, please.
Yes, please.
Okay. So the standard with which a physical quantity is compared with is the unit. Example of unit is a kilogram, meter, second, etc. and etc. Okay. So when we measure time, we are looking at the quantity of an unknown time to a known time, and the known time is 1 second. So if I determine the time taken by an athlete to complete a race, and I get 2 minutes, what it means is that the time used by the athlete to complete the race is 120 times the known, which is 1 second. Are we fine?
Yes.
Please.
Okay. If you finish, let me continue. Now, when a physical quantity is measured, whenever we measure a physical quantity, we express whatever we got or we measured or whatever we compare to the known, okay, by its magnitude. by its magnitude. So a magnitude of a physical quantity. Let me give you something on magnitude of a physical quantity. The magnitude of a physical quantity is a pure number with a proper unit. It's a pure number with a proper unit. Example, we have 10 meter, 10 kilograms. Here, the pure number here is a 10. And then the unit is equal to kilogram. So whenever we measure a physical quantity, we have to express it by its magnitude. And magnitude of a number, magnitude is equal to a number times the unit. That is why when we take measurement of value and the unit is not well defined, we write maybe so and so number, example 10, and the unit, because that is not stated, we write unit. The unit compensates for the whole writing of unit compensates for U, so that it will be complete for magnitude. Okay, so the whole word unit stands for the unit which is not stated. Ideally, it should have come, but because that is omitted, it is compensated by the normal unit. Most of the times, we overlook it when it's not stated. So if the magnitude is 10, in our usage, we use 10 and ignore the unit because it's an indication that it is omitted. But it is written to give meaning to the word magnitude. Please, are we okay?
Yes,
Yes, please.
All right.
Yes, please.
yes, please.
Now, the whole number, and then a unit of a physical quantity are always related in this way. Number is that inversely proportional to unit. Okay, Eresi, your hand is up. Let's hear from Eresi.
Mr. Idria.
Hello.
Please, magnitude is equal to, I can't see the expression
Magnitude
there.
is equal to N times U, where N represents the number, the numerical value.
Yeah, okay.
Okay, and U represents the unit.
Yes, sir.
Meaning that when we are expressing physical quantity by the magnitude, there should be a certain number, okay, telling the extent of how it relates to the physical quantity, the standard measurement, and its well-defined unit. So the N represents the number, and U represents the unit. Okay.
Okay, thank you very much.
All right. Now, the number and unit. Number, I mean pure number. As in this case, 10. Relates to unit by this way. We are saying that number is inversely proportional to the unit. Now, in measurement, When two quantities are said to be inversely proportional, what it means is that the quantities relate in such a way that when one increases, the other one decreases. And when one decreases, the other one increases. Please, are we clear here?
Yes, please.
What I'm saying is that when two variables or quantities relate, and the nature of the relation is such that they are inversely proportional, then what it means is that when one increases, the other one will decrease. When one decreases, the other one would increase. So that is it about inverse proportionality. Let me adjust the screen so we can use the other parts of the board. So inverse proportionality. When two quantities are inversely proportional, or what we say variable, inversely proportional, an increase in one causes a decrease in the other, and vice versa. Justine, your hand is up. You can't see from the, you can't
Yes,
see from
please.
the other end.
Yes, please.
Is it better?
No, please, not really.
I'm coming. It must be better now.
Yes, please.
Go.
Yes, please. Thank you.
Another kind of relationship we so much talk about in physics is direct proportionality. So we've talked about direct proportionality. And we'll be using this kind of relation in dimensional analysis. That is why I want to, speak about it ahead of time. Okay. I want somebody to share. Aqua. Priscilla Aqua. Priscilla. Oh, okay. I want somebody to help us. If you have an idea about this, share with us. What we mean by direct proportionality between two variables or quantities. One, two, Joyce. Joyce, go ahead.
Please, thank you for the opportunity.
All right.
Okay, please, when two variables are directly proportional, an increase in one causes an increase in the other.
Exactly.
And a decrease in one causes a decrease.
Thanks for coming. So, yes, when two variables relate in such a way that they are directly proportional, an increase in one results in an increase in the other, but not of the same magnitude. When this increases, the other one would also increase. When this one decreases, the other one would also decrease. Please, can somebody give us a practical situation where two variables relate directly and inversely? Can somebody share with us a practical situation or a known variables that relate directly and also relate inversely? Can somebody share that with us? Okay. If you don't know, let me draw your attention to density. What is density? Or give me the formula for determining density.
Mass over volume.
Good. So density is equal to mass over volume, or mass per unit volume. By the relation, what it means is that density is directly proportional to mass. And the same density is inversely proportional to volume. What it implies is that mass, when mass increases, density also increases. Please, do you agree with that? That when mass increases, density would also increase?
Yes, please.
Yes.
Okay. And when density, volume increases, density will decrease. When volume decreases, density would also increase. So an increase in this would cause a decrease in density. A decrease in volume will cause an increase in density. Okay, so this is a typical example of the two relationships we talked about. Do you have any questions? If you have any questions, quickly ask and let's continue. Another example we can talk about for these two relationships is pressure. What is the formula for determining pressure? Pressure is
Force
equal
over
to
Force on area.
force over area. So from here, we could deduce that pressure is directly proportional to force. Pressure is inversely proportional to cross-sectional area. So this explains a direct proportionality. Then the area explains an inverse proportionality. Okay. You can talk about a lot. But let's come back to what you were doing. Please, are you done writing what is at the extreme right?
No, please.
Yes, please.
Okay, hurry up, and then let me reposition the board. Okay. Now we're talking about the relationship between number and unit. And the relationship is such that number is inversely proportional to unit.
Mr. Ria,
Okay. Hello.
please, I can't see where you are writing.
I'll reposition the I hope it's better.
Yes, please. Please, thank
Okay.
you.
So somebody asked of the definition of direct proportionality. With direct proportionality, I said it is the relationship between two quantities or variables such that an increase in one would result in an increase in the other. A decrease in one can also result in a decrease in the other. But please, it's about two or more physical quantities. It isn't only two. It can be two or more, right? All right. So the relationship between number, which is a pure number value, and then unit is that as unit increases, number n decreases. Okay. Christine,
Mr. Edward, please, I didn't get a definition for the direct proportionality.
direct proportionality. With direct proportionality, an increase in one results in an increase in the other, and vice versa. Okay, so it can be the other way around. When one increases, the other one would also increase. When one decreases, the other variables would also decrease. That is for direct proportionality. For inverse
Edward, please,
proportionality, all right. So when unit increases, number decreases, and vice versa. Example, you see, if I have 10 kilograms, 10 kilograms, here the unit is kilogram. Kelly, I'm coming. The unit is kilogram, the number is 10. Now, when the unit changes to gram, gram is a smaller unit. Let's see what will happen to the number. Okay. How many grams would give you 1 kilogram? But before then, you see, 10 grams means that 10 times 1 kilogram. Do you agree with me? 10 grams
Yes,
means 10 times 1 kilogram. Let's change 1 kilogram to gram. What is 1 kilogram expressed in grams?
1,000 grams.
Good. 1,000 grams. So what it means is that a magnitude of 10 kilograms is equal to 10,000 grams. And look at it. When the unit is smaller, the number is huge. Here, this is the unit. This is the number. When the unit is smaller, the number is huge. When the unit is bigger, the number is smaller. And so this relationship. Number is inversely proportional to the unit. When the unit increases, number decreases. When unit decreases, number would increase by the example stated below. Please, are we fine?
Yes, please.
Yes.
Yes, please.
All right. Now let's understand. I want you to help me understand. So as we are doing, as we started measurement, we were talking about. Please mute yourself. I'm getting a very bad feedback here. If you haven't muted, do so for me. We are talking about physical quantity. Physical quantity. What is a physical quantity? What do we mean by a physical quantity? Yes. Anyone to share the meaning of physical quantity with us? Nana Markusi.
A physical quantity is defined as anything that can be measured or quantified.
Okay. Okay, more views. If your hand is raised, please go ahead. Joy.
A physical quantity is a quantity that can be measured by an instrument or by calculation.
Okay.